So my name is Pratna Sekar, and I am the manager for the solutions engineering team here at Keysight for our design data and IP management products. The topic for today, we're going to be discussing about leveling up your SOC or chiplet design game. And how we're going to do that is by optimizing using IP-driven approach. Now, right off the bat, I'm going to tell you that I'm not going to talk about how you should do your actual design and how to do all these things. That's not what I do. I don't know anything about that. But I will tell you that in the evolution of chip design, so for many years now, SOCs have been at the forefront of complex technologies. But the complexity of semiconductor chips in some sectors like automotive, defense, healthcare, now these areas need a little bit extra technological support beyond that. Chiplet technologies, they make it possible to integrate different technology nodes into one single IC. So chiplets are our next, the next frontier of silicon system or subsystem development. Why? Because they bring you modularity. Chiplets are smaller, they are more specialized for doing certain specific functions, and you can put them together, mix and match them, and get your optimal functionality. Besides modularity, they're also very cost effective, and the smaller a chip is, the less likely you have. I mean, you're going to have defects, but fewer defects. So that's reducing your manufacturing costs. You also have the flexibility when you're using chiplets, where not everything has to be equally in a manufacturing sense. It doesn't have to be overly complex or latest and greatest technologies for the entire parts. Maybe there are some parts that need that cutting edge manufacturing technology that could be expensive, but some other parts don't need that. So it gives you that cost effectiveness. And overall, chiplets offer this unique value proposition because they're flexible. You can adapt them, you can mix and match them, especially with different technology nodes. So when you are building with chiplets, if you think about it as you are integrating different IP blocks from different vendors, for example. If you think like that, if you think with an IP-driven mindset or approach, you're going to need a strong IP-driven methodology to support this thinking, and this will help you when you're developing such complex designs. And I'm going to talk about what some of the challenges are when you are thinking about IP-driven methodology in the traditional sense, and what solutions we have to offer. So, so typically, when you're talking about an IP-driven development methodology, let's consider a regular customer, mid-size. You're talking about hundreds of IPs. They have several different combinations that you can do with their revisions, with their flavors, and this will produce different chip variants. But there is a problem here. The biggest problem that engineers face when they're trying to do this iteration, right? Several iterations of does revision 3 of the I2C or revision 2 of an SPI in a microcontroller block, and then you have an LED driver. It could be anything. It doesn't matter. But the point is, you have different versions and different flavors of IPs. You are mixing and matching. You're going through iterations, and it takes time. And not just that, it also takes up a lot of your network storage in a certain sense. So, and people who are used to doing this, you will understand why this is a problem. So when you're switching through different configurations, loading of those configurations, they also take substantial time. So when you, for this example, like you see, I'm talking about a project repository here that say maybe has 100 gigabytes of data. And in a traditional data management system, you would have these individual user work areas all replicating all 100 gigabytes of all that data. So now think about all the switching that you're doing with your IPs and configurations, trying to find that secret sauce for whatever that functionality is. It's going to take a long time to load, and it's going to take a lot of your network storage. So let's take a look at the other challenges before I jump into the solutions. Now, let's say you found, out of 100 different iterations, you found maybe 20 meaningful configurations that work for your functionality, your design, and you want to now share it with people of either your own team or different teams. And you want to have a way of tracking this, naming this, saving this, everything in the database along with the design, and anybody else should be able to replicate this configuration easily, right? And if you're not able, if you don't have the right tools to do this, this can be a very, this needs extensive management in terms of record keeping, and it's not possible to do it if you don't have tools that support this IP-driven development approach. And last but not least, you do have, with all these complex configurations that you're working with, there's bound to be some IP version conflicts. And you would ideally want to run your IP reports on what is being used in your design at every different stage, making sure, somewhere it's not being flipped to use the wrong stuff. So you want to have good reports that give you what IPs are being used, but also if there are conflicts, there are different version of IPs being used, same IP being used in the same design, that would be a red flag. So for some of these challenges, what are the solutions that we offer? And by we, I mean we have our Keysight's design data management product called SOS. And so what I'm showing you on screen right now is actually our graphical user interface for SOS. And this is actually a tree of, for this particular project, which is called an IP catalog project called IPCat. And you see all the different IPs in here. This particular one, blue one that's highlighted there, is the ATPG IP. It's a digital IP. Now, what else do I know about it? Just by looking at this GUI, right? I get the information about where it's coming from, the exact path, the project, what release am I using in this consumer project, and I have all the different versions of that particular IP, and the current version that I'm using happens to be release 1B, which is highlighted. So just by looking at it, you get all this good information about whether it's an internal IP, external IP coming from a different project, or what version, and maybe I'm not on the latest version of that particular IP, which is okay. Maybe I want to be on a properly released version. So all this good information comes from our tool, which is very IP aware. So this particular feature that I'm showing here is the referencing feature. And it's very important when you are using an IP-driven approach for your design development. Now, another great feature we have is something called sparse populate. Now, earlier I talked about the challenges that engineers face when they have to iterate through hundreds of different IP releases and flavors, mix and match them, and when they do this, there's obviously going to be slow turnaround time. So how do we make it faster? Basically, if you used a sparse populate feature, what you're doing here is that ATPG, that same ATPG IP here, is not even, it's just one single symbolic link into the actual IP that's sitting in your cache, right? You don't even get to expand it and see the revisions or what's in it, but you have the design in your, you have the ATPG block in your design right now. It's usable in your, whatever integrations you're using it with, like Cadence or Synopsys, and it's there for your, if it's a read-only reference, the best way to do it is sparse populate that object, and what it gives you is network storage optimization. You're not using a lot of disk space, and you're not using a lot of inodes. You're only using one symbolic link per IP, and that's pretty cool. And our other solutions here, we have something called work area configurations, where when I talked about mixing and matching different IPs, IP releases, now you have to, how do you remember them when you find the right ones? You have to give them a name, save them in the database. You have to be able to share them across teams. And so the way to do it would be with work area configurations. In this case, you can just see a quick snippet here where the PLL library here is using tapeout 1A, and it's all saved nicely into the project. And this is the PLL 1A variant, but you could have several different variants, and it's all named and very easy to find. So you can just simply tell your colleague and your who's in a different team, load up this PLL 1A variant configuration and run your simulations, and you should see what I'm seeing. So that's a very useful feature, and I was talking about reporting IP conflicts early on and at every stage, so that you don't end up in this difficult situation where you find out too late that, oh, I've used different versions of the same IP in different places in different hierarchical levels, and that would cost you a lot of time and money for sure. So to prevent that from happening, we have useful reports that you can just run quickly, and it immediately tells you where there are conflicts. In this case, you can see the digital ATPG IP. It's the same IP that's coming from the same IP project, but you can see they're on different releases. One is on release 1A, but in another place in the same project, it's just using the latest version. Now, with all these solutions, we have more solutions when you think about an IP different methodology using the design data management project from Keysight, but I want to highlight this one, which is the impact that our tools provide, or the impact that our tool has on network storage optimization. So I'm going to take this quick example here of a large FPGA design team, and they have this mixed signal project which has like about 44 IPs. They're coming from 4 different vendors, and these IPs could be anything. I mean, they're like open access libraries, soft IPs, hard IPs, verification IPs. It doesn't matter. It's, for this particular customer, they had this kind of a mix. And if you look at the number of user work areas they had 120 of them. And each work area was 185 gigabytes. Now, in a traditional system, you are looking at a total network storage of 185 gigabytes times 120 work areas, which is like 22 terabytes. And that's a lot of network storage. So if you used SOS, and all our customers use this core feature, which is called links to cache work area. And you can also go one step further and use the sparse populate features that I was talking about earlier. But with the very basic links to cache work area model, you immediately are talking about just symbolic links for all those schematics and layouts pointing into the cache. So your size of each object just reduces because you don't have physical copies of those objects in your work area. All you have are symbolic links pointing to the cache. And now when you look at that, 57 megabytes times 120 work areas, and let's say that this customer had 3 different sites, so they built 1 cache per site, and the cache size was about 185 gigabytes, for the project. And you do the math there, and you end up with just about 600 gigabytes, which is immediately a 97.3% saving. It could be different based on what objects you want in your work area. It could be even lesser in terms of network storage consumption. But right there is a huge impact. And with that, I just want to highlight some of the things that I talked about today. The summary is that, if you're doing SOC or chiplet design, and if you think about it from an IP-driven approach, you have several advantages towards yourself, which is high operational efficiency, because now you have a very streamlined process. You know exactly where your IPs are coming from, whether they're internal, external, what versions you're using. You can make them, those configurations, managed very well, shared very well across different teams, and faster turnaround times. And of course, you're saving a lot of disk space while doing all of this. And you have very good traceability, which is the most important thing when it comes to an IP-driven approach. So with that, thank you very much.